Hello. So far we discussed the properties of functions and the information that we can obtain from the graph of a function. In today's lesson we will look at combination of functions and we combine functions. But those are the normal skills that we have done already. You can add two functions, subtract functions, you can divide one function by another, and you can do many combinations of functions. Let us start by looking at two functions, f of x equal to x squared minus 5x and g of x equal to 3x minus 2. In what way we can combine them? What is f of x plus g of x? Well, that's very simple. Add f of x plus g of x, and that gives you x squared minus 2x minus 2. How about the domain of f of x plus g of x? Well, the domain of f of x plus g of x is what is common to the domains of f of x and g of x. Well, in this case, the domain of f of x is negative infinity to positive infinity. The domain of g of x also is negative infinity to positive infinity. What is common to both? Well, negative infinity to positive infinity. Is that right? That's right. So the domain of f of x plus g of x is negative infinity to positive infinity. How about f of x minus g of x? Now, take care when you subtract one function from another. After the subtraction sign, enter the second function in parentheses and then distribute the negative sign and simplify. Now, how about the domain of f of x minus g of x? The same rule applies to that as well. So the domain of f of x minus g of x is also negative infinity to positive infinity. Well, what is f of x divided by g of x? Is x squared minus 5x divided by 3x plus 2. Now, what is the domain of this? Well, in this case, the domain cannot contain a value of x that will make the denominator 0. So we set the denominator equal to 0 and solve for x. When x equal to negative 2/3, the denominator becomes 0. That means you cannot have x equal to negative 2/3 in the domain of that function. So x equal to negative 2/3 is not in the domain of f of x over g of x, although the domain of f of x is all real numbers, the domain of g of x is also all real numbers, the domain of f of x divided by g of x does not contain x equal to negative 2/3. So we will write it like this: negative infinity to negative 2/3 union negative 2/3 to infinity. Alright, let's look at another one. If f of x, find f of x plus g of x, f of x minus g of x, and f of x divided by g of x for f of x equal to square root x plus 1 and g of x equal to x minus 5. Alright, that's very simple. F of x plus g of x is this quantity. How about the domain of f of x? Remember, the domain of this quantity does not include numbers that make the quantity x plus 1 negative. That means x plus 1 has to be greater than or equal to 0. That will give x is greater than or equal to negative 1. So the domain of f of x is negative 1 to infinity, but the domain of g of f is negative infinity to positive infinity. Now, the domain of f of x plus g of x is what is common to both these. What is now common to both these? It will be -1 to infinity, -1 included. That's right. That's the domain of f of x plus g of x. Now, look at the graph of f of x plus g of x. The domain includes only -1 to infinity. There are no numbers less than -1 in the domain of the function. How about f of x minus g of x? Well, f of x minus g of x is, we subtract g of x. What is the domain of this? Well, the domain of this also does not contain numbers that are less than -1. It is also -1 to infinity, and look at the graph of f of x minus g of x. Well, by now you know that the best way to find the domain and range of a function is actually doing the graph of that function. Okay. Now, what is f of x divided by g of x? That will be square root x plus 1 over x minus 1. Alright, I want you to look at this and tell me what is the domain of this f of x over g of x. If you look at the numerator, the domain of the numerator does not contain numbers less than -1. The denominator cannot have x equal to 5, is that right? Well, x equal to 5 will make the denominator equal to 0. Alright, so the domain of the numerator is -1 to infinity, -1 included, and the denominator cannot be 0. That means the domain cannot contain x equal to 5. So, what is therefore the domain of f of x divided by g of x? It will be -1 to 5 union 5 to infinity. Now, does -1 include in the domain? Yes, it does. So it must be actually a bracket, not a parenthesis. So it'll be square bracket, -1 to infinity, union 5 to infinity. It means 5 is not included in the domain. And you can see here in the graph of f of x over g of x, the x equal to 5 is not in the domain. There's a break in the graph at x equal to 5. Let's do this for these two functions. F of x equal to square root x plus 5 and g of x equal to square root x minus 2. We need to find f of x plus g of x, f of x minus g of x, f of x over g of x, and their domains. Alright, that is no problem. F of x plus g of x is, add those two. What is the domain of square root x plus 5? The domain of square root x plus 5 is -5 to infinity, -5 included. The domain of square root x minus 2 is 2 to infinity, 2 included. It is common to both these. Well, you can see this interval is contained in this interval. Therefore, what is common to both is this. And so, the common interval is 2 to infinity, and that is the domain of f of x plus g of x. Now, that's the graph of f of x plus g of x. The domain is from 2 to infinity. How about f of x minus g of x? What is its domain? Is it different from the domain of f of x plus g of x? Not really. Look at the graph. F of x minus g of x, the domain is again 2 to infinity. Alright, how about f of x over g of x? Well, we have the denominator cannot be 0 in this case. Is that right? That means you cannot have x equal to 2. And so the domain will be 2 to infinity. Is that right? Now, what is common to both these domains? The domain of the numerator is -5 to infinity. The domain of the denominator is 2 to infinity, where 2 is included. But because this is a denominator, 2 cannot be included, because when x equal to 2, that becomes 0. And therefore, the domain of the combined function is 2 to infinity, 2 not included. And this is the graph of f of x over g of x. You can see as x gets closer and closer to 2, the function goes to positive infinity. All right. Now, there is another way to combine functions. It is called the composite functions. What is the meaning of composite functions? Composite functions, one function is made up of another function. What does that mean? Well, if you take one function and use the input of that function as another function, then you get the composite of the two functions. So, composite of two functions is where the input of a function is another function. But that may be a little difficult to understand. Let me see if I can give you an example to illustrate it. Now, suppose you walk into a car dealership. Now, almost everybody is familiar with the concept of haggling the car prices. Is that right? You can't go and buy a car for a fixed price in this country. You got to go and bargain, haggle. So, you walk into a car dealership and talk to the first salesman. And he will, of course, tell you, I'm going to give you the best possible deal. Now, a car always comes with a sticker price. But if you pay the sticker price, you will be considered almost an idiot. Because nobody pays sticker price for a car here. So, if X is the sticker price, the first salesman gives you a deal. He says, you buy any car of sticker price X, you get $2,000 cash back. So, there he is actually defining a function for you. X is the variable because there are so many cars in the dealership. So you can go and pick any car you want where X is the sticker price. Tell me, what is that function? What is the function that salesperson is offering you? Well, that function is f of x equal to x minus 2,000. This is what the first salesperson is offering you. You go, you pick any car of sticker price X, you get $2,000 cash back. So that's the function offered by the first person. Are you satisfied? No, you can get a better deal. So you go to another person. Not satisfied, you walk over to another salesperson. And that person offers you another deal. What is the deal? He offers you to sell you a car for 90% of the sticker price. Alright, what is that deal? What is the function then? If X is the sticker price, what is the price that he is offering you? G of X equal to 0.9x. So, if you take that deal, your buying price will be given by G of X equal to 0.9x. You can go and pick any car and that will be your buying price. So, the first salesperson gives you this deal, f of x equal to x minus 2,000. The second person gives you this sales price, G of x equal to 0.9x. Are you satisfied? Well, if I were you, I will not be. So I will walk into the manager's office and see what he has to offer. And now he makes an offer. He says, I'm going to make an offer that you cannot really, well, turn down. So he offers you $2,000 cash back on 90% of the sticker price. Now look at that. He's actually taking the two functions and using one as the input of the other. We are now going to get a composite function. Is that right? The manager is offering you $2,000 cash back on 90% of the sticker price. So what the manager is doing is, the manager took the first function and then used the second function as an input for it. So what is the deal? If the manager's deal is h of x equal to 0.9x minus 2,000. In other words, you can take any car and you get $2,000 cash back on 0.9x of the price. Now, if you look at f of x equal to x minus 2,000, look at this. If this x is replaced by h of x, if this x is replaced by g of x, in other words, in place of this x, if you put 0.9x, then you get h of x. In other words, you use g of x as the input in f of x, you get h of x. You have now a composite function where the input of function 1 is function 2. All right. So in the function f of x equal to x minus 2,000, if you replace this x by g of x equal to 0.9x, you produce the third function h of x. And so we now have a composite function. H of x is a composite of f and g. Now, how did we produce h of x? We produce h of x by taking f of x and replacing the input by g of x. So the input of f of x becomes g of x, then you get h of x. In other words, what you have produced is, remember, when you say f of x, we are saying that the input of that function is x. But in this case, the input of this function is g of x. So we should now be calling the composite function f of gx. That's right. That is the way to write a composite function. So we now got f of gx. The input for f of gx is g of x. So replacing x in f of x by g of x, we produce f of gx, because this is the input. And this is the composite of f and g. I hope you understand the concept. Now, how do we write it? F of gx. Now, f of gx is generally written like this. Look at that small circle there. That is the O made it into a very tiny O. So this is f of gx. That's right. This is the composite is a function of x. So we call it f of gx. Now that means in the function f, g is the input. And both are functions of x. All right. So to obtain the composite function f of gx, which is equal to f of gx, what all we need to do is replace x in f of x by the function g of x. That's a very simple process. Now, how about the domain of f of gx? Now remember, in f of gx, the input is g of x. So the domain of f of gx is such that x has to be in the domain of g of x, and then g of x has to be in the domain of f of x. That is the criteria for deciding the domain of f of gx. We will take a couple of examples and show that to you. All right, let's look at a question. Find f of gx and the domain of f of gx for f of x equal to 1 over x plus 1 and g of x equal to 1 over x. Tell me, what do you do to find f of gx? F of gx means in the function f of x, x is replaced by g of x. In other words, you replace this x by g of x equal to 1 over x. When this x is replaced by 1 over x, you get f of gx. That's right. So, look at the way I've done it. F of gx is 1 over, in place of this x, I wrote 1 over x. And now, simplify this. What do? In here, take x as the common denominator. Yes. When you take x as the common denominator, what will be the numerator here? It will be 1 plus x over x, and that will be the numerator. So that will be 1 over 1 plus x over x. That simplification is not difficult. And now, 1 over 1 plus x over x, what will happen to this x? It will go to the top. So that will be x over 1 plus x. Alright, what is the domain of that? The domain of this does not contain, you can see f of gx is x over 1 plus x. The domain of this does not contain x equal to -1. And also there is one more thing that the domain does not contain. What is that? The domain of g of x does not contain 0. Now remember, the domain of f of g is such that g of x must be in the domain of f of x. So g of x does not contain x equal to 0. Any number that is excluded from the domain of g must be excluded from the domain of f of g. Therefore, the domain of f of gx does not contain x equal to -1 and x equal to 0. So how do you write it? It does not contain x equal to -1. It does not contain 0. So we say -∞ to -1 union, -1 to 0. That means -1 is excluded. Then union 0 to infinity. It means 0 also is excluded. Okay. Let's try another one. This time we have 1 over square root of x, and g of x is x plus 5. Find f of g and the domain of f of g. I'm sure you can do that now on your own. To find f of g, what do? In the function f of x, replace your x by what g of x is. So this x will be replaced by x plus 5. Alright, so f of gx is 1 over, look at this, in place of x I have x plus 5. Now what is the domain of this? The domain of this, if you look here, the denominator cannot be 0 and x plus 5 cannot be negative. So the domain there is -5 to infinity. And if you draw a graph, now look at the way we can actually draw the graphs of all these functions. I want you to try this on your own. Go to your calculator, press y equal to, and put in y1 equal to 1 over square root of x, and y2 equal to x plus 5, and y3 we can give a composite. Look at the way it's going to be. It's going to be f of x. Now f of x means in y1 x is replaced by y2. So what all we need to do is say 1 over square root, you see, square root x, instead of x we say it is y2. 1 over square root y2. And how do you get y2? Do you remember? Well, you need to press vars, locate vars on your computer, press vars, go press the right arrow once to see the y variables, and then enter. You will get the y1, y2, y3 and so on. So the first one is y1, the second one is y2. So take the cursor down to y2, enter, you will get y2 there. Alright? Okay, so how does the graph look like? Well, that's the graph of f of x, and that's the graph of g of x. So I'm drawing them. In the last lesson I told you how to deselect some of the graphs and then plot them one by one. You can see I plotted the first two and then I deselected those, and now I'm ready to plot the third one. And this is the graph of f of gx. And you can see its domain contains only -5 to infinity. -5 is not included. That's right. Okay. Let's do another one. F of x equal to x squared plus 3. And g of x equal to square root 4 minus x. And this time we need to find f of gx and g of fx. What's the difference here? In f of gx, we use the input in f, the function g. In other words, x in f of x is replaced by the function g of x. How about g of fx? In g of fx, f is the input for the function g. In other words, x in function g is replaced by f of x, and that will give you g of fx. Okay, now our f of x is x squared plus 3, and g of x is square root 4 minus x. So, what is f of gx? In order to find f of gx, we replace x in f of x by g. You can see x squared. In place of x, I wrote square root 4 minus x, which is g of x. Alright, now when you simplify a square root quantity squared, the square root will disappear. That will be 4 minus x plus 3, which will be 7 minus x. Well, what is the domain of this? Well, if you look here, 7 minus x, it looks like the domain is negative infinity to positive infinity, because there isn't a number that is not allowed here. But you must say, since this is a composite function, now the domain is not all reals, is it? Well, this is defined for all values of x, but you can see g of x is defined only for x values such that 4 minus x is greater than or equal to 0. Is that right? That means x is less than or equal to 4, or the domain of g of x contains only numbers 4 and less than 4. And so, what is the domain of f of gx? It will be negative infinity to 4 and not negative infinity to positive infinity. The domain is only up to 4 included. Now look at the graph of this. Again, put in y1 equal to x squared plus 3, y2 equal to square root of 4 minus x, and look at the way y3 is entered. y3 is, you can see y3 is f of gx. Now here, x is to be replaced by g of x. And now g of x is y2. So in place of x, we write y2. y2 squared plus 3. That will give you f of gx graph. Alright, that is g of x, and this is the graph of f of gx. For some reason, my y1 graph is not appearing here. But of course it is a graph like this, is that right? That would be a parabola. And f of gx is this. You can look at this. The domain contains only numbers 4 and less than 4 for f of gx. Okay, how about g of fx? G of fx is obtained by replacing x in the function g by f of x. That means this x will be replaced by x squared plus 3. So you can see that x is replaced by x squared plus 3, and now simplify it. 4 minus x squared minus 3, that will give me 4 minus 3 will be 1. So it is simplified as square root of 1 minus x squared. What is the domain of this? Can you work it out and tell me what is the domain of 1 minus x squared? How do you do that? Well, 1 minus x squared has to be greater than or equal to 0. Is that right? Yes. Now, if you notice here, the graph of f of x, the graph of g of x, and this is the graph of f of g of fx. And look at the domain of this. It is from -1 to +1. Now, how do you obtain that domain from here? Well, you should be able to do that from elementary algebra. If you don't remember it, let me show it to you. Now, in order that the quantity inside the square root sign may be greater than or equal to 0, we say 1 minus x squared is greater than or equal to 0. So let me write down that. 1 minus x squared is greater than or equal to 0. It means 1 is greater than or equal to x squared. Now, can I write it as x squared is less than or equal to 1? Yes, absolutely. Now, what does that mean? It means absolute value of x is less than or equal to 1. You take the square root. Absolute value of x is less than or equal to 1. What it means is that the values of x is between -1 and 1. Only then will absolute value of x be less than or equal to 1. Alright? Okay. So the domain of f of gx, as you see from the graph, is -1 to 1, both endpoints included. Well, another one. F of x equal to 16 minus x squared, g of x equal to square root x squared minus 16. Find f of gx, g of fx, and their domain. Alright, I'm sure if I leave it, you will be able to do that. Now, to find f of gx, in f of x, we replace this x by g of x. In other words, x will be replaced by square root x squared minus 16. So, it is f of gx is 16 minus square root x minus 1 quantity raised to the power of 2. And when a square root quantity is raised to the power of 2, the square root will disappear. That gives me 16 minus x squared minus 16. What is that equal to? That will be 32 minus x squared. Tell me, what is the domain of this? 32 minus x squared. Well, the domain of that is actually all real numbers. But does it mean that f of gx has the domain -infinity to +infinity? No. Why not? Because the domain of g of x is not negative infinity to positive infinity. Now, what is the domain of g of x? Can you work out that? I'm sure you can. Now, although this is defined for all values of x, g, the domain of g of x is such that x squared minus 16 is greater than or equal to 0. Now, that means x squared is greater than or equal to 16, or absolute value of x is greater than or equal to 4. So, what's the domain of g of x? It contains negative infinity to negative 4, union 4 to infinity. In other words, no numbers from negative 4 to 4, well, 4 and 4 are in the domain, but numbers between negative 4 and 4 are not in the domain. Therefore, the domain of f of gx is negative infinity to negative 4, union 4 to infinity. Alright, draw a graph of this and see whether this is true. Well, here is the graph of, this is g of x, and look at the graph of f of gx. These two pieces are the graph of f of gx. You notice that there is no graph of f of gx between negative 4 and 4. That means numbers between negative 4 and 4 are not in the domain of f of gx. So you should always verify these things graphically. Okay, now we need to find g of f of x. To find g of fx, what do? In the function g, x is replaced by f of x. That means this x squared becomes 16 minus x squared all squared. Well, we're not going to simplify that, we're going to leave it that way, because simplifying will not really simplify it. Now, the domain of this does not contain values of x that make 16 minus x squared. In other words, the domain of this does not contain values of x which make this quantity less than 0. This is not really true. You see, the domain is such that this quantity must be greater than or equal to 0. And that means this quantity cannot be less than 0. So those statements must be very clear. So when I have a mistyping, you must identify that immediately. So what does it mean? The domain of this does not contain values of x that make this quantity less than 0. It can be 0 because square root of 0 is defined. Alright. Now if you draw the graph, you can see g of fx is this graph, and what is the domain of it? You can see the domain, this is the graph of how many pieces are there? There is one piece, a second piece, a third piece. That is the graph of g of fx. That means there are values that are not in the domain. And I'm going to leave it for you to solve this, and that's a challenge. You can solve it and send it to me. You will get 2 extra credit points. Now, what is the equation I want you to solve? Take the quantity inside, 16 minus x squared all squared minus 16. That should be greater than or equal to 0, and solve for x. And you can see the domain is therefore negative infinity to negative 4.6, union negative 3.5 to 3.3, union 4.6 to infinity. That means numbers between negative 4.6 and negative 3.5 are not in the domain. Numbers between 3.3 and 4.6 are not in the domain. Alright? So I would like to hear from you about this. Okay, how to find we have another problem. Find f of gx and g of fx and evaluate f of g negative 1 for f of x equal to 3x and g of x equal to 2 plus x. Well, that's a very simple process, is that right? All we need to do is find f of gx and then replace that x by negative 1. Alright, f of gx, this is f of x. F of gx will be in the function f of x. We replace this x by 2 plus x. So that will be f of gx will be 3x, that is 3 times 2 plus x. And that will be 6 plus 3x. And therefore, what is f of g negative 1? F of g negative 1 is obtained by replacing x by negative 1. That will be 6 plus 3 times negative 1, which is 6 times 3, that is 3. Alright. And if you want to find the g of fx, what do? In the function g, x is replaced by f of x. So that will be g of fx is 2 plus, in place of x, I have 3x. 2 plus 3x. And therefore, if you want to find g of f negative 1, it will be 2 plus 3 times negative 1. That is 2 minus 3, that is negative 1. Okay, another one. F of x equal to 5x minus 1 and g of x equal to 2x plus 4. Find f of gx, g of fx and f of g negative 1. It's a repeat of what we did earlier so far. So to find f of g again, what do? In the function f, replace x by g of x, that is 2x plus 4. So that will be 5 times 2x plus 4 minus 1. F of gx is 5 times 2x plus 4 minus 1. Simplify that, that will be 10x plus 20 minus 1. I have forgotten my 1 there. And so it will be, if I want to make that correction, what will that be? So this is going to be 10x, f of gx will be 10x plus 20 minus 1. And that will be 10 times negative 1 plus 20, then a minus 1. That will be negative 11, is that right? This negative 10 with the negative 1 will be negative 11 plus 20, that will be 9. So f of g negative 1 equal to 9. And to find g of fx in the function g, we replace x by f of x. And that gives me 2 times, in place of x, I have 5x minus 1 plus 4. And that will be 10x minus 2 plus 4. That is 10x plus 2. Well, these were rather very simple exercises. Alright, now I'm going to give you a composite function like f of gx equal to square root x squared plus 1. Can you think of two functions f of x and g of x such that when g of x is used as the input in f of x, you get this function? Is it possible? It's a very simple exercise if you understood the process. f of gx equal to square root x squared plus 1. What are the possible forms of f of x and g of x? Well, the simplest way to look at it is, since x squared plus 1 is a quantity inside the square root, we can call that equal to g of x. Is that right? Yes. So this x squared plus 1 can be g of x. But remember, g of x is the input for f of x. That means f of x now has to be square root of x. Right? If f of x is square root of x, and that x is now replaced by g of x, x squared plus 1, you get f of gx. Is that simple? Alright, so since f of gx is produced by replacing x in f of x with g of x, it's easy to see that we must take g of x equal to x squared plus 1. Now, if g of x is x squared plus 1, and remembering that in producing f of gx, this g of x takes the place of x in f of x, then the only possible way is that f of x must be square root of x. So if f of x is square root of x and g of x is x squared plus 1, then f of gx must be square root of x squared plus 1. That's right. Okay, I'm going to give you an assignment now. Think about this. On the other hand, can we have g of x equal to x squared? Suppose if we choose g of x equal to x squared, what will be f of x? We can do that. In other words, what that means is these kind of questions have no unique answers. You can actually have different answers. That's right. So I want you to get back to me with this, if you have an answer. If you choose g of x equal to x squared, what will be f of x? Alright, another one. Obtain the possible forms of f of x and g of x such that f of gx equal to 5x plus 2 all to the power 4. Well, give me a possible g of x. You've got to start with g of x. What's a possible g of x? It's very simple. You can take that quantity as g of x. If this quantity as g of x, and remember the x in f of x is going to be replaced by g of x to produce f of gx. So then what will be f of x? F of x then will be x to the power of 4. That's right. So we take g of x equal to 5x plus 2, then f of x will become x, because in producing f of gx, it is that x that will be replaced by g of x. So your function f of x is now x to the power of 4. Alright. Another assignment. Can you find another form for this answer? If you can, let me know. Now, also consider this when you get back to me. I will give you another assignment. If f of gx equal to 5 over x squared plus 1 to the power 4, what are the possible forms of f of x and g of x? Alright? Get back to me with this. Think about it. Alright? Let's do a couple more of these before we move on. Find possible forms of f of x and g of x such that f of gx equal to 1 over x minus 2. You must have got the hang of it by now. Well, obviously, we can choose our g of x to be x minus 2. Is that right? Yes. So if g of x equal to x minus 2, what is then f of x? F of x must be 1 over x. So in f of x equal to 1 over x, this x is replaced by this g of x to produce f of gx. So we take x minus 2 as our g of x, then f of x will be 1 over x. One more. F of gx equal to absolute value of x squared minus 2. Give me the forms of f of x and g of x. I'm sure you must be talking to yourself by now, and that would be a good sign. Alright, what is the form g of x we can have? One possible g of x is the quantity x squared minus 2 can be called g of x. If g of x is x squared minus 2, then what will be f of x? F of x will be absolute value of x. That's right. Okay, that's been very simple. And finally, let's see if we have an application problem. The demand x and the price p of a certain product are related by x equal to 5,000 minus 100p. Now where p is between 0 and 50, 0 less than or equal to p, less than or equal to 50. The cost of producing x units of the product is c of x equal to 20x. Express the profit as a function of p and find the price that produces the largest profit. But actually, the problem is very simple. It is not as big as the problem itself. I hope you understood the various terminology used in here, which is normally the terminology used in business. What other things we have here? The demand x for x number of products. You want x number of cars, x number of motorbike, x number of radios. Whatever you produce, x is the number of things you produce and sell. So the demand x and the price p. P is the unit price per one article. The price of one car, the price of one television, and so on. Now, the cost of producing x units is c of x, cost as a function of x. X is the number of units, is that right? Equal to 20x. That means the cost of producing each unit is $20. Cost of producing x units is $20x dollars. Express the profit as a function of p. Now, how do we get profit? I'm sure some of you are doing business. Now, what is the profit for a business? Well, when you produce and sell things, there's a certain amount of revenue coming in. And then from the revenue, you take away the cost. That is your profit. So, you got to first of all find the revenue. What is the revenue? Well, here we've got the demand x is 5,000 minus 100p. And we have cost equal to 20x. So, if x units are sold at p dollars a unit, that is what is given to us. X units, x number of items are sold, and each item is priced at p dollars. What is the revenue then? The revenue R is x times p. Is that right? Yes. Now, we are told that x equal to 5,000 minus 100p, so we replace this x by this function. This is a composite function. Revenue function is a composite function of, well, R of p of x. In R of p, x is replaced by this function. So when x is replaced by 5,000 minus 100p, It becomes 5000p minus 100p squared, and that is the revenue. And therefore, we know the cost function. Cost function is C of x equal to 20x, and we know that x equal to this, so let's express the cost also as a function of p. Since we need the profit function in terms of p, we have revenue as a function of p, and we also need cost as a function of p. Cost is given as a function of x, but x is given to us as a function of p. So what we need to do is, this x is replaced by its value as a function of p here. Cost is 20x, and in place of x we write 5000 minus 100p, and that is 100,000 minus 2000p. Well, we have revenue as a function of p, we have cost as a function of p. Can you find the profit? What is the profit? Profit as a function of p will be revenue function minus the cost function. And that will be, revenue function is this, 5000p minus 100p squared, minus, take care, you are subtracting a function, therefore use the parenthesis, minus the profit function is, what the cost function is 100,000 minus 2000p, so that will be revenue function minus the cost function. Now simplify that. Well, you distribute and then combine like terms, you come up with this. Negative 100p squared plus 7000p minus 100,000. This is the profit function as a function of p. What does p stand for? P is the price per unit. That's right. Now, what's the question? Express profit as a function of p, which we did, and find the price that produces the largest profit. So what you would expect, if you notice here, this is actually a second degree function with a as negative. So if you follow some of the discussions we have, it will be a parabola that opens downward. That means you would see as the unit price increases, the profit will increase, and the profit will reach a maximum, and thereafter if you increase the unit price, the profit will decrease. You see, those who do business know that. You see, if you're selling cars, and if you see so many cars are selling, you keep increasing the unit price. If you keep increasing the unit price, the profit will go up. But after a certain increase in unit price, people would say, oh, those cars are very expensive, so I'm not going to buy them. That means the demand will go down and your profit will decrease. So there is a certain value of the unit price that will bring a maximum profit. That is what we need to find. So what all we need to do from the skills you have learned so far is to graph this function. Now, how do we graph it? Can you graph this function on your own? In place of p, you use x on your calculator. So, go to your calculator, press y equal to, and type in y1 is negative 100x squared plus 7000p minus 100,000. That's right. There is the function. And of course you need a scale for this. To produce a scale, you must have a certain idea about the values of this. And I'm going to ask you to try this. X minimum is 20. X maximum is 50. X scale is 1. Y minimum is 0. Y maximum is 30,000. And when you do this and graph, there is the graph. and you need to find the maximum value. You remember how to find the maximum of a graph using the calculator? Well, if you have produced the graph, what you need to do is follow the instructions I have given you for maximum. What do? Well, you need to go and find the maximum value of the function. Alright, I have the graph now on the calculator for you to see. Now, what do we do to find the maximum? Press second, the second button is out of the screen. So second trace, there you are. And you have maximum, minimum. You want maximum, that is number 4. So press number 4 and you have left bound. Now, for the left bound, what all we need to do is move the cursor somewhere to the left. So I'm going to press the left arrow, see, 2-3 times, and press enter. And then it asks you for the right bound. So I press the right arrow so that it goes to the right of the bend. And then I press enter. And then the calculator want to guess. And for that, just take the cursor back to the center where you think is the maximum. That's a guess. And now enter. Well, the calculator has now done the maximum value for you. Now, what does it show? It says the maximum occurs at x equal to 35. Read it as 35. And the maximum at that time of the function is 22,500. In other words, remember, this graph is a graph of the profit as a function of the unit price. So it says when the unit price is $35, you get the maximum profit. That is what it means. So you should be now, we have done several exercises like this. Practice some of this on your own. And if you have any questions after doing the homework, get back to me. All right?